points, and then we'll go ahead and get started into the webinar. First of all, you will be on mute during today's call. If you would like to ask a question, you can either type it in the text box on the right-hand side of your screen, or you can click the button to raise your hand. We'll try to monitor this as closely as possible and get those questions answered as quickly as we can. We will allocate a couple minutes at the end of the webinar for an open question and answer period. With that, we'll go ahead and get started. The topic for today's webinar is solving production problems and going from a reactive to a proactive situation. And what we mean by this is adding the capability to allow us to look ahead out into the future and make those decisions which will reduce our risk and improve our execution capabilities. I'd like to briefly provide an introduction of the panelists on the call today. You have myself, Derek Bentley, a Managing Director of Arvense Group, and two individuals from PlanetTogether, Pete Nelson, the Director of Solution Development, and Scott McMartin, the VP of Sales and Marketing.
Thank you.
Scott, thank you for joining today.
Thank you for letting us participate.
Pete, are you with us? Okay, we had a couple audio problems last Tuesday when we were in this with Pete, so we may be experiencing those as well. We'll try to get him back on here, but we'll move forward until he joins with us. So with that, let me go ahead and provide a little background information on Arvense and PlanetTogether and the partnership that we've formed here. Arvense Group is a management consulting firm focusing on delivering innovative solutions in the oil and gas, automotive, and aerospace industries. And PlanetTogether is the Galaxy APS developer. APS stands for Advanced Planning and Scheduling. They've developed this software over the last 10 years, and it's now deployed in about 120 organizations globally. Really, the reason for standing up this partnership was to leverage some of the synergies which existed between the two firms, and Arvense is going to take lead on the business consulting and the thoughtware side of it, whereas PlanetTogether is going to take lead on the systems integration and the software elements. We're confident moving forward that we'll be able to provide more value to our customers because of this partnership that we've formed. Just a brief run through of what the presentation will consist of today. First, we're going to have an introduction to the differences between APS and the current ERP solution, and then a brief overview of constraints management. Then Pete, assuming his audio will come back on, will give us a demo of the Galaxy APS software, and finally we will look at some of the next steps. So here we have the 5 stages of continuous improvement. Today we're going to go through the realize stage, and that's where we start to learn how the modern APS solution can improve business as it is today. Then we get into the visualize, synchronize, optimize, and capitalize phase. We'll introduce these concepts throughout the presentation. With that, I'm going to go ahead and turn it over to Scott and let him talk a little bit about the differences from APS and ERP.
Thank you, Derek. Okay. Well, thank you all for attending today. I just wanted to briefly cover the differences between, what an ERP system, or previously called MRP systems, but now called ERP system, is capable of doing and what its main purpose is, and what an advanced planning and scheduling solution is responsible for performing within the organization. They are called different things. ERP, Enterprise Resource Planning, really essentially suggests that it's really the enterprise system of record. It's a database essentially of all the transactions that occur within the company, ideally. Although there may be times when there could be some other systems that are not operating within the ERP system for some good reason. But generally, it's an enterprise transaction system of record. One of the differences between that and an APS, because the dot is not there, is that we consider the APS system to be a value system. So whereas the ERP is the enterprise transaction system of record, the APS is the engine of value creation. This is the way we term it. The next item that is uniquely a characteristic of an ERP system is that it's essentially the source of past performance reporting. Whereas the APS system is more of a forward-looking solution. It really is taking a look at the current order profile and telling you that you either are or not going to be able to meet the commitments that you've made, or if you can meet the commitments, how well you're going to be able to meet those commitments from a profitability point of view. So what the ERP system would do is to tell you how did you do after the fact. So one is a proactive or forward-looking system. The other is a recorder of actual performance. Now, both systems actually share the material requirements planning, the rough cut capacity planning, and the available to promise capabilities that are typically found in the MRP/ERP environment. The reason for that a lot of times is that many clients that we work with don't have, sophisticated ERP systems. They may have a collection of spreadsheets and other database technology sources that we have to integrate to. So, but at the end of the day, we still have to create production orders, and we have to have the bills, the routings, all the things that are typically in an MRP system or an ERP system. So that's why you'll see these three things. Now, the one I want to focus on primarily is this available to promise idea. Available to promise typically is essentially oriented more around material availability. It can be somewhat associated with resource availability, but generally it's one or the other, never the two together. And that's a pretty significant departure from the ERP system that the APS generally will bring to the table. And we'll talk about that a little bit later. But essentially what we want to do is we start getting into the areas where the APS is uniquely different from an ERP, is that the constraint-based modeling of resource capacity and material flow, these two things simultaneously are evaluated as you're making commitments to your customers and as changes to the schedule occur, and we are looking for alternatives to continue to be able to fulfill the promises that we've made to customers. So it's this simultaneous evaluation of both capacity and material that is the real key here. The other significant differentiator in my mind is the visual and the financial decision support tools that are available in the APS. Typically, companies that are looking for planning and scheduling are looking for some kind of visual planning board. Sometimes they might even be coming from a physical planning board that's on the wall. And the typical approach to addressing that within the advanced planning and scheduling system is what we call a Gantt chart for doing drag and drop movements within the schedule to test different scenarios that might be more beneficial to your firm's ability to meet its commitments. But the other thing that I think makes this really interesting is the financial indicators that are also available. So when you do make a decision to move an order to another, to another production line or another work center, the implication of that from a cost and a throughput point of view is made very clear to you immediately. So the immediate feedback on the financial side is really powerful. That kind of leads into the what-if scenario, simulation, and comparison. So because APS systems typically operate in memory, they're able to actually do the simulation work that you'd like to do in an ERP system or an MRP system, but don't have the physical resources or the time to do in that environment. So the APS system provides a very high-speed MRP generation, if you'd like to look at it that way, but it allows you to do what-if scenario simulation about different options you might have. Do I want to add overtime? Do I want to outsource an operation? Do I want to go to an alternate routing or an alternate path? Those kinds of questions can be answered immediately by virtue of the what-if scenario simulation and comparison capabilities that are in the APS system that you'll be looking at today. The other key area that companies that are looking for advanced planning and scheduling start to look at systems like this for is the idea of schedule generation. They want a system that will optimize the schedule as it's generating the schedule to be executed against. The reason for that is that most planner schedulers spend quite a bit of time trying to get to the point where they've got something they could send to the floor that they might have a hope of executing in support of keeping commitments to customers that have been made. So what the APS does, the Advanced Planning and Scheduling System does, it actually does about 95% of the heavy lifting of actually creating the schedule. So once the schedule is created, which generally occurs in seconds to minutes probably, depending on the size of the organization, the knowledge that's generally held, with the planner scheduler is now becoming much more valuable, because now you can take a pretty good schedule. It's probably never going to be as good as the planner schedule, if they had enough time, could put together on their own. But once the schedule is generated, the planner scheduler now has the ability to manipulate that schedule to really take advantage of their knowledge of the dynamics of the manufacturing environment that they're generally planning and scheduling day to day. So this really frees them up to be much more proactive and much more strategic about the way they're evaluating options that are available to them. Strategic buffer management. This is a really critical thing, and if you're looking for advanced planning and scheduling systems, if they don't have this, this is a problem. The big issue for manufacturing typically is the fact that no matter what you plan, and you're generally planning to standards, the world around you is just never going to honor that. And people aren't going to show up for work, machines are going to break down, the weather's not going to cooperate, trucks are breaking down. Customers, believe it or not, are going to change their mind about the orders that they've given you. They want more, they want less, they want them moved out, they want them moved in. To some extent, the variability associated with all of those events I just talked about can be managed through a buffer system that essentially absorbs the negative effects of the variation that typically is associated with the manufacturing process. So having strategic buffer management as part of the solution is absolutely critical. So the first thing, assuming unlimited material and capacity availability, that's the #1 problem that planner schedulers face. It's not realistic in the first place. And then once you get the schedule, if you don't have the ability to buffer yourself against the variability that's also inevitable, you're just fighting a losing battle. So those two things in particular are very critical. But at the end of the day, what the APS system does that the ERP system cannot do is it provides a proactive and focused planning tool. Now, what we get to is the real holy grail for a lot of companies, and that is once I've got a good schedule, and I want to commit new business to the production operation, I need to have the ability to do capable to promise. This is different from available to promise in that it actually evaluates simultaneously capacity and material and any other constraints that are unique to your operation. So all of these things on the right-hand side really truly make an advanced planning scheduling system a tremendous opportunity for companies that have realized they just cannot do what's necessary to make the proper commitments to their customers, and then not only make them but keep them. So I think you're going to see some very interesting capabilities as we proceed with the presentation. So thank you for the opportunity to at least explain the difference. Okay, so what typically happens is the environment that you operate in is just fraught with symptoms, really. Lots of things are going on inside the organization that are just causing people to pull their hair out. One of the things that typically comes up is you don't know that there's an order that's late until the customer calls and asks you where it is. It would be nice to eliminate the need to have to call them in the first place proactively to tell them that the order might be late. But if it is going to be late for some reason, the ability to address that question or that issue early on is really key. But this issue of customers calling, wanting to know where their orders are, and not being able to give them a quick answer is pretty much a commonplace thing. Scheduling new orders. How do you put new orders into the system that you've just spent all that time, creating? When the world changes, which is going to be probably the next 10 minutes from now. So scheduling new orders is generally a very, very difficult thing for most planners and schedulers. The lack of visibility, which is really the one word that people use when they talk to us initially, is I just have to have visibility. I just don't know what's coming at me, and it's the lack of that visibility that really causes a lot of tension between sales and operations. And this is another area that we think we can address by putting you in a much more proactive position. One of the other things, frequently changing order priorities. Every 10 minutes or so, every hour, customers are calling in with new requests. They want to change things. There's all kinds of stuff that's just affecting your ability to keep the promises that you've made. And then the other thing is, do you feel that you're wasting capacity? I think it's just sort of an innate feeling of dread that pervades most manufacturing organizations, is that they're just running around firefighting, doing what's necessary to satisfy the customer, knowing that they're just not doing the right thing in terms of the getting the most out of the capital resources at their disposal. And at the end of the day, this sort of manifests itself in every order on the floor now becomes a hot order. It's which customer's squeaking is screaming the loudest, where's the squeaky wheel. And so what happens is, because the schedules in the first place are not very realistic, the world around us continues to challenge our ability to do what we've planned. It becomes just kind of an enterprise-wide firefighting drill, and that's just a very frustrating way to run the operation. We can go to the next one, please. So what we want to do is move from that to something that's a little bit more, has a little bit more sanity. Obviously, we want to run a profitable operation, but by profitable I mean you need to earn profits that are greater than your cost of capital. Otherwise, why be in the business with so much risk and so much stress? You've got to generate profits, obviously, but you've got to generate significant profits to justify having all of that capital tied up in machines and plant and equipment, that kind of thing. So let's start at the bottom of this pyramid. Nothing good in any business really starts unless you have a customer. So the two things that generally people come to us for is to affect their delivery performance. Most people are worried about on-time delivery because that's how you keep the current customers that you have. I want to make the promise, I want to keep the promise, and I don't want to put my customer in a position where they have to go back to their customer and tell them that they can't meet the commitment that they've made. So that on-time delivery thing, the reliability element here, is pretty key. And today, if you're not operating in the high 90% range, 97, 98, 99%, then you're probably not really competitive, and you're probably not going to be considered as a market leader. We know that if you implement the systems properly, APS system properly, you can achieve that. The other issue is, how do I get new business? Typically that's associated with responsiveness or lead time. Lead time also has some other interesting implications in the area of inventory, obviously, and the cost of carrying that inventory. But responsiveness is the key to winning new business. You should ask yourselves, or at least talk to the salespeople in your organizations, how many times are you losing business because you can't respond fast enough? How many new customers could you have brought in that are currently doing business with your competitors who have failed them, and they've come to you and said, can you meet my need in less time than I would normally ask you, and have to say no to them? I've talked to customers recently that have been turning away, even this year, millions of dollars because they don't fully believe they have the capacity, they don't believe that they can deliver fast enough. So reliability and responsiveness are key. Now that you address the high delivery performance block, which is a pretty key element of running a profitable business, you also need to have the capabilities to put a predictable and proactive scheduling environment in place, and that's what the APS system is really all about. That's kind of what we create when we put these things in place. And then if you are proactive in terms of the planning and the scheduling and the execution of the plans, you're going to control your costs. You're not going to have the overtime. You're not going to have the expedited freight. You're not going to have to do the outsourcing. You're not going to be expediting orders through the plant. All of those things that are required to brute force orders through the system so that you can meet your commitments are just going to be essentially cost drivers that are just going to really challenge that profitability picture at the top of the grid. So this is the picture that we can create if we properly implement a planning and scheduling solution like the one we're talking to you about today. Thanks.
Thank you, Scott. I just want to briefly check your audio feed. Is it working again?
Wow.
Okay. Hopefully we'll get that fixed between now and the next couple minutes. Let's transition into how to get there. Now Scott has really addressed the concept of where we want to be. We want to be a profitable organization. So I want to introduce the idea of a constraint. And really what this is it's there are two types of constraints. One is a policy constraint, and the other is a physical constraint. On the policy side, I'm going to use an example from a last engagement that I was on. The company had a department with 14 extrusion mill machines, and this department was known to be the constraint for the organization. It was always working overtime, and it always had part shortages. They generally had accepted that as the department as the organizational constraint. So we entered into the department and said, why was not great, but okay. The other thing that we found was around shift changes, they were doing a very poor job with their handoffs, and they were losing a considerable amount of capacity during that shift change. About 3 out of the 14 machines were all that you would count running for about 30 minutes in there. So we simply posed a question to the first level manager and said, how can this be improved? Immediately he realized that a policy that he created was by and large causing this decrease in capacity. He had put a policy in place which said that right when at the beginning of the shift we'll have our huddle meeting, and then you'll go out and get your machine started for the day. Well, he changed that policy, and he changed it to at the beginning of your shift, the first thing you focus on is getting your machines up and running, and then we'll come in after 45 minutes into the shift and we'll do our huddle meeting. This, combined with a couple other injections, allowed the workshop to increase their throughput by 26% in a matter of a couple weeks, and it removed them from the organizational constraint. It reduced their overtime, and it reduced their part shortages. So that's what's critical to keep in mind. We need to assess the policies that we're putting in place and make sure that they're the most effective for creating capacity. The other type of constraint is the physical constraint. And what the physical constraint is, let's use the example of a piping diagram you see here on the right side of the screen. The object of this pipe is to flow water through it, and we want to increase the amount of water that we can flow through the pipe. What are we going to do to improve that flow? We're going to increase the diameter around the segment labeled 3, right? We need to make that larger so that we can flow more water through the pipe. Everyone pretty well agrees on that. Now, the important part is that we've got to get agreement as well that we can make as many improvements around the 6s, the 5s, and the 10 as we want, and we won't affect the delivery capability of the entire system. The only way that we're going to affect the output of the entire system is to improve that one segment. Okay, so let's keep this example in mind, and let's go to the next slide. And go ahead and click twice, Pete. And we're going to introduce the idea of variability. And this is going to be in the form of labor shortages and machines breaking down, like Scott spoke about on a couple slides back. We know that this happens day in, day out, right? There's a difference between the short-term versus the long-term systematic constraint. And we need to understand that we can manage this variability if we know it exists in the system. So go ahead and click one more time, please. This is where I want to introduce the concept of drum buffer rope. And what drum buffer rope is it's a way for us to ensure that we get the most possible out of our constraint by allowing it to run at its natural rate in isolation. And the way we do that is we develop the drum, which is at the constraint, and that becomes the cadence for the entire organization or the entire pipeline, right? Then we put a buffer in front of it. This buffer can either be in time or parts so that we protect it against the variability, the upstream variability. We can also put a buffer behind it so that we never block it from being able to finish parts and get it off of the machine, so that we protect it from the downstream variability. But all we're trying to do is manage that variability. It's just like a shock absorber on a car. Then we take and we tie the rope to the release of materials coming into the system so that we never get too much WIP or work in process throughout the system. What this will do is it'll allow us to keep our inventory down, and it'll allow us to reduce the amount of chaos and confusion on the shop floor. I don't know how many times I've been out in manufacturing settings when they've released a bunch of orders and there's just clutter sitting around the shop floor, causing a ton of confusion, a ton of multitasking, and clogging up the system. This concept of drum buffer rope will really help us keep from getting in that scenario. So with that, I'm going to try to turn it over to Pete. We'll see if his audio is working yet, and he's going to take us through a demo of the Galaxy APS software.
Hi everyone, this is Pete. Can you hear me now?
Pete.
Hey,
Awesome.
sounds like just in time. So
I'm for the dramatic.
That's right. I had you all on the edge of your seats there for a second. Really looking forward to giving you a quick walkthrough through an example of an APS called Galaxy from PlanetTogether. I'll walk you through that visualize, synchronize, optimize kind of a flow, taking a particular focus on the visual tools first, but I do want to focus on those power tools that Scott and Derek mentioned, including buffer management, being able to do what-ifs, optimizing your schedule, and most of all, being able to drive some measurable results. So that's the pathway we have in front of us in the next few moments. Now, as I tab over into Galaxy, you'll notice that it is a very graphical representation of a manufacturing schedule. This is a visual scheduling board that displays any number of resources and items and orders that I'm interested in. Galaxy itself is built for more than one plant and location. Those are laid out here on the left-hand side in terms of tabs, but I chose this morning to take a look at a very simple type of a process with just 3 steps involved in my resources, and we can visually see that here on the graphical board. So as I open up this side here, we're able to see that there's a first step in the process that runs through a capacity constraint and goes on into a third step. And visually here, we can track that right in front of us. And the colors do mean something. You'll see the effect of those in just a moment. The idea here is we maintain all the constraints and relationships in materials and capacity as things flow through. So I can see that the first step flows right into my capacity constraining resource, where it takes quite a bit of time to run that process before it gets handed off into the third step for that same job or production order that I'm interested in scheduling. And likewise, of course, for today I wanted to keep it very high level and simple to understand, but as you add more complexity, more resources and items and orders, and that's really where the power of the number crunching of the computer can really help out to manage things. Now, one other key concept is the idea of the colors that happen here, and to illustrate the real-time flexibility of Galaxy in particular, if any changes occur, because I've got such a tight flow from my first step into my capacity constraint, if that moves from Monday morning, let's say, out until Tuesday morning, there's going to be a pretty big impact on my schedule if that occurs. Galaxy's smart enough to be able to react to that and show me the results of any change to my schedule. So although job number 1, VSO1, is on time here, the beginning step starts to run into the yellow where I might have some problems there, but I definitely have some problems there on my capacity constraining resources if that were to occur. Now, I do that on purpose just to illustrate some of the user friendliness. A lot of folks start with the idea of, if we only had that visibility and the ability to schedule faster, we'd be in much better shape. And I think that's a part of it that you want to accommodate right away. From a user productivity point of view, real easy thing to do inside of Galaxy is to undo any changes that you make to your schedule. So I can come right up here to my undo menu, rewind back to things I was doing earlier today, but I'll just undo that last change just to give you the sense of part of being successful with a change to your planning and scheduling approaches, getting great buy-in from those all-important planners and schedulers in the first place. You got to feel confident that you can try out things in the system and make sure that they all happen. Now, I also show that drag and drop capability, not to just illustrate that constraints are a big part of that no matter where they occur in the process, but also to talk about the importance of those buffers that go on top of managing good data. I actually do have a very good plan here in front of me where, if nothing goes wrong, I'm going to be in good shape. Job 1 will complete on time, that's in the green, and job number 2 will complete on time, although just barely, it's in the yellow zone there. But even though I've got good data and an optimal schedule here, we can see that if real life doesn't follow along with what the plans and standards say, I could run into trouble. So how do we protect ourselves against that risk, knowing that, some likelihood there's going to be some minor disruptions along the way? Well, part of that is that drum, buffer, rope planning. The drum, in this case, is going to be my capacity constraining resource where I want to focus my attention and make sure I don't miss out on any of the all-important capacity there. Just to show you some of the differences between this forward, do everything as soon as possible type of an approach to some of the benefits of a smarter approach using drum buffer management here. I'm just going to change my rules to apply that type of a technique. And now when I click Optimize here, Galaxy in fact is looking at all of my resources and items across all of my plants in this case to come up with a better schedule. But we'll see that right in front of us in a moment here as we run through that particular scenario. So I can see in this case that I can still accommodate meeting those delivery dates, but I'm doing it in a different fashion that requires not just the software to do this, but the thoughtware and discipline to make this happen. Job number 2, in order to have a good chance of being on time, does need to move up to the front of the schedule, and unfortunately we're basically out of buffer there, so we have to go right into the capacity constraint to get that job done. But the good news is we can actually wait until Tuesday afternoon to release the materials to begin that first step. We can wait right until this point to begin working on that operation, and we know we can do that because there's still plenty of buffer time, which is, according to my desires for running my little demo company here, I've got plenty of room there that if that job doesn't start on Tuesday afternoon, it could actually start on Wednesday afternoon, and it doesn't impact the schedule on my constraining resource, although I get the visual cues that I start to run into trouble if that slips and slides a little bit further into the future. So that's kind of a quick illustration of this importance of not only optimization and having good information and data in front of you, but also being able to run the business with the idea that disruptions are going to occur. We want to protect ourselves in a smart way from those happening and be able to see when we might need to pay special attention to that buffer penetration and what might be going on inside the system. Now I made all these changes here inside of my live schedule, and in a multi-user environment that's okay to do, but often you want to try out different ideas and share them and collaborate before you make any decisions. And one of the great things about planning and scheduling is to be able to do those what-ifs. In Galaxy, you can have any number of these what-if scenarios, which lets you try out different ideas to solve the problem. So maybe rather than doing the drag and drop there, I'm going to come up with a different way to make those changes. So it protects you, gives you a little bit more of a sandbox to play in to be able to try out some wonderful ideas before you commit to them. And again, it's very important in multi-user and multi-factory environments. Now to show some of the optimization that can go on at the end of the spectrum, once you're visualizing and you're synchronizing with your buffers and have good policies and procedures in place, now you can really start getting the most out of a planning and scheduling system very quickly. And for this example, I'm going to go to a different plant in my scenario where I've got a bit more happening just to illustrate the idea of this optimization that takes place. As a matter of fact, I'm going to focus in, rather than looking at all the resources and tools that are involved here, let's just take a look at our production area and look at our machines and equipment first. Now here I can see I do have a job that's in the red. I've got different sources of machines and equipment that could do that, and I actually have optimized the schedule as we saw before according to my delivery dates. Now the problem with these types of products is there's a bit more to it than just my dates. I'm going to show a little bit of information that hopefully is not too overwhelming at first. I'm going to show a little stripe of color at first that will show me the amount of changeover or setup involved and the amount of runtime. As I apply that change, now I've got, again, that visual where I can see that job number 5, if it runs after job 10, is going to cost me 2 hours to set up before I run it for 9 hours. Now there's a reason for that we call product attributes that affect the changeover time. So this is a pretty common example where we want to strike that balance between being efficient with the use of our resources, but still meeting our dates, keeping our costs down where they need to be. Now anytime I want, I would set those rules inside of Galaxy to give you an idea of the flexibility and personalization I can do. I did build my schedule according to just one factor, my delivery date at first, but I want to blend in the importance of being efficient. And in fact, I'm going to make that the most important factor to try to squeeze out some of that setup time wherever possible as I go along. Now Galaxy's smart enough to know that it's not one or the other or a choice between different things. It's really a blend of the weights of those different factors. So Galaxy's going to consider everything that I allow it to as it comes up with a better schedule. So I am in my what-if scenario. Here as I go ahead and click that optimize again to go ahead and rebuild my schedule, I can see that I do a little bit better a job squeezing some of that setup time out of my schedule, but I wasn't able to completely eliminate that on all of my resources. Now the graphical board is just one of many different ways of working with the system and seeing what's happening. A particularly powerful way to see at a high level whether I'm getting the results I need is to compare my scenarios, any number of them, with all the great ideas that I have with my team to build a better schedule. And what we see here is one row at the top for our live schedule that has about 35 different measures that we keep track of at all times. And my second row shows that this is my ninth what if of the day. As I look across at my key indicators, I can say I really didn't change my financial throughput or my operating expenses, but I would expect to see as I scroll across that I did have somewhat of an impact on the amount of setup time in my schedule. And that should follow from the decision you just saw me make, that if setup time is important and I have the opportunity to optimize around that, I was able to go from a little over 2 hours per day to about an hour and 50 minutes or so on a daily basis. So about a 10% reduction is not bad, and in some industries that can be very significant in terms of its impact. So there is some data that's required to do that. There are measures that are tracked at all times so that you can really validate, are we running the business in the right direction, at the same time that your users are in a very good environment for getting their work done in a productive fashion. And it's that kind of complete view from software and thoughtware that we in the Arvense Group aim to strive for with each of our clients as we go along. So I'm going to tab back into our show here, turn it back over to Derek to carry us on through to some of our concluding remarks before we take some questions.
Yeah, thank you for that. Just quickly, I want to recap and kind of go back through what we talked about. We really, what we're trying to do with all this, introducing the software, introducing the thoughtware, we're trying to go from this chaotic system to where we are profitable, where we have a better control over our internal operations. And that's the whole purpose of this. So let's talk a little bit more about the next steps and how you can get there in the follow-on. Moving on to the next one, an exercise. Okay, the first step is, what do we focus on? What do we do in the short term and then now to the next few weeks? And that's why we've created this exercise, and really think about value from the customer's point of view and say, what's the value of improving your production? And then what's keeping you from achieving this? So we've put down a couple standard goals which our clients often are trying to achieve. You can see those on the left side here: reduce quality, improve on-time delivery, reduce inventory. But you need to come up with this based on your customer's point of view. And then say, okay, if we do this, what's the value of achieving that? What's the percentage of the feasibility, the percentage that will be successful, and then the cost associated with that, and how long is it going to take us to get there? After you do this, it will allow you to be able to compare that cost to your value, and then you can kind of frame in your mind what the best way to move forward is. Moving on to the next slide, we want to wrap back around to the 5 stages of continuous improvement that we introduced earlier. The realize stage is kind of what we've had today, where we start to see the APS may be able to help me in my organization. The next 3 stages are the ones that we can progress into over the weeks and months to come. And the visualize stage is where we'll go through, we'll map the process, identify the constraint, have a clear capacity plan, and really start to manage that constraint, that we can see what's going on in the organization. That's where you'll use some of those powerful Galaxy APS tools. Then we move into the synchronize phase. And this is where we really start to understand the drumbeat of the organization, and we release materials based on that constraint. Additionally, subordinate the other resources around it so that everyone throughout the company is synchronized and all to one drumbeat. Then we have the optimize. In the optimize, we can do the what-if scenarios to get the most out of our constraint. Also, we'll apply the lean concepts here so that we can ensure that we reduce the waste at that constraint resource. Finally, and this is important when you can't stop at optimize, the capitalize phase. That's where we go back to the customer base, communicate this additional value, and we can either sell more work or sell to a new market segment, improve margins, things like that. Really exploiting that competitive advantage that exists after you've created it there. So then finally into the next steps, what are they? First of all is to reflect. Reflect on this and say, really, am I adding value to my customers, or am I introducing problems to them? And then, are my policies creating or destroying capacity? And if you find out if it's the negative of either one of those, what can we change to improve that? Then identify or look for areas in your operations that you can improve that. Next, you can schedule a follow-up call to discuss these concepts with myself or Scott. We'll give you the contact information as we close out here. You can schedule a webinar. We have a couple different options, a 4-part webinar series. And this is where we'll go into more detail on the TOC concepts, the DBR, the lean, and really start to get a better feel for Galaxy APS. We'll approach the issues in a systematic way, thinking about it from that customer point of view. The other option is to schedule an on-site tailored workshop. This is a 16-hour workshop. We'll get into the value stream mapping, start to understand the power of the what-if scenarios that really help enable that better decision making, gain a deeper understanding of the TOC and lean concepts, get to do some tutorials with the Galaxy APS software, and then finally is just go ahead and schedule an assessment. An assessment would include all of the things which are in the workshop or webinar series, and it would be about a 2 to 4 week time period for a single location. This would include the goal identification, the stakeholder analysis, the value stream mapping, the definition of the business requirements to enable the software, and identification of internal constraints, and then finally a business case, which would be the plan to move forward with the implementation. So these are really the ideal next steps. As you see, we've got our contact information here. Reach out to either myself or Scott to discuss these topics further.